All right, guys, hang on to your seats. I'm going to do one problem video here, but this one problem has every single thing I need you to know from this section in it, and maybe even then some. All right, so hang in there. I'm going to go pretty slowly. If I were you, I'd watch this in more than once because, like I said, it's got every single thing in here. So the words are so important. We'll read the problem first. Excuse me. It says a .01 significance level is used for hypothesis tests of the claim. Here's the claim that when parents use the XOR method of gender selection, the proportion of baby girls is greater than 0.5. So first of all, the claim, if I were just going to write the claim would be P is greater than 0.5. That's the claim. Assume that the sample data consists of 55 girls born in 100 births, so the sample stat of 0.55 results in a z-score that is one standard deviation above 0. So that's actually telling you some answers here, but I'm going to go ahead and show you what we would do if we didn't even know that. So part A, identify the null and alternative. Okay, the null, I think we're great at this already. Remember, the null must have equals, so the null would be that the P is 0.5. The alternative would be that it's greater than 0.5, which is what the problem said is. So the alternative is the claim. Now, part B says, what is the value of alpha? Alpha is the significance level. That's all that means. This, when you see that symbol, that's what the significance level is. It tells you up there in the first line of the problem, it's 0.01. That's all you do there. Part C sounds weird when you first read it, but you got to remember what it's talking about here. It says, what is the sampling distribution of the sample statistic? Now, because we're doing, there's three kinds of sampling distributions. There's a normal, there's a t-distribution, and there's a chi-square distribution. Because this is a proportion, it is a normal distribution. So we're going to use the normal distribution. So my calculator, I'm taking inverse norm, normal CDF. If you're doing StatCrunch, you're looking for normal. Okay, part D says, is this a two-tailed, left-tailed, or right-tailed test? And this was in one of the videos. We haven't made a big deal about this in class yet. We will tomorrow. Look at your alternative hypothesis. It says P is greater than. And because it's pointing to the right, and the greater than is on the right side of your normal distribution, it is right-tailed. If it was less than, it would be left-tailed. If it's not equal to, that's when it's two-tailed. So one more time. It is right-tailed because it's greater than. If it's left-tailed, that means it's less than. Two-tailed means it's not equal to in your alternate hypothesis. Part E, what is the value of the test stat? Okay, we did two of those in class yesterday or today or whenever it is you're watching this video, and we did this. We did Z, because it's a proportion, equals our P hat, which is 0.55, minus our P, which is 0.5, over standard deviation of P times Q over N, which is 100. Punch out that in your calculator, and you get 1, which is not a surprise because that's what they told me up there. The z-score from the sample stat is 1. That is the test statistic. So the test statistic is 1. Big deal right there. The test statistic is 1. Here's what I know so far. I'm going to shrink a lot of this stuff. I know I'm using normal. Okay, normal curve looks like this, kind of. I know that my sig level is 0.01, so that's out here. That's 0.01. My test stat is 1, which is a z-score. That z-score is 1. That's right there. I'm going to skip F for a second. Well, let's do this. It says find the p-value. The p-value is the area it's talking about, like past the 1. How much area is past the 1? So I'm going to take my calculator right now, and I'm going second vars. Number 2, normal CDF. My lower is 1, my upper is 1,000. Going to paste, boom. And I get this, I get 0.1587. 0.1, so that's my p-value, which is a big deal. 0.1587, that's my p-value. Then it says, what's the critical value? Another word. The critical value is where we got from our significance level. Significance level, remember z-crit? That's what that is. Significance level, z-crit, all talking about the same thing. So it wants to know what is my z-score right there where my significance level is. So there I'm going second vars. I'm doing inverse norm. My area is 0.01. And I'm going to the right. Make sure you go to the right. And you get 2.33. So that's 2.33. What is the area of the critical region? That's the area past the critical value. These two words go together. Critical value, critical region. The critical region is your significance level region, and it is 0.01. That's the area of the critical region. Now, guys, that is a problem that has just about everything in it. Now, we're not worrying about so far. We're not rejecting or failing to reject the null, that kind of stuff right there, but we are finding all the values, and that's extremely important. So watch this once or twice, 8, 9, 14, 15 times, whatever it takes. Really good problem. It has everything in it. So I'll see you tomorrow, and we'll finish this up. See you then.